Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our tree series. So the name of the question is recover BST. So let us have a look into the question that what we have to do in this question. So let us go to the board. So in this question, a BST will be given to us. Okay, this is a BST and it is given to us. And what we have to do is in this question there is something like the two nodes. Suppose these two nodes, the data of these two nodes is being changed. It is like this right now it is BST, right? See how we can see it is a BST. We will traverse into it in order and we will see if the in order is sorted or not. So let me write the in order for it so that we can see if it is a BST or not. Okay, so let me write the in order. So here we have an array and we will write the in order of this BST in this array. So first one, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. Okay, so we'll write it here, and it should be 8. No, in order, right? So how we'll do in order? Traverse it. This one is the first one in the in order, right? So 1, then 3, then 6, 6 will come. No, 6 will not, right? 1, then 3, then 4, then 6. 1, 3, 4, 6, and then 7. After this 8. After this 10. After this 13, right? 6, 7, 8, 10, 13, and then 14. 10, then 13, and then 14. It should be like this. Okay, so what we have to do? See, in this question there is a little change in the BST given. Like there are two nodes for which the data has been replaced. Suppose 6 and 10. Okay, it is 10 now, it is 6 now. This data is being replaced. Okay, so it will look like 6 is here, right? So here is 6, and in the array it would be like 6 is being changed to 10 and 10 is replaced with 6, right? So here we'll have 6 was there, right? So here we'll have 10 now and here we'll have 6 now. Okay, so this is the change. This is the change that is given in this BST, and what we have to do, we have to recover our old BST. We have to recover our BST, and we have, first of all, how we can do this? First of all, we have to see that if there is some change or not. If there is some change, what we have to do, we have to identify the place at which there is a change. Okay, at which there is a change, we have to identify those places. And but one more thing, only one change is there. Okay, only one pair will be changed, only one pair is replaced. That is, only two nodes data are replaced. Okay, so you have to see that where are those two nodes. You have to again set them, like again change their data and again make it a BST. This is how you will recover your BST. Okay, this is how you are going to recover your BST, but there is a condition. That condition is you should use the space complexity of O1. You should not take the space of not even O1, not even recursion space. Okay, not even stack. So you should not use recursion here, right? You should not use recursion here. So what you can do, think about it. So if you are thinking a correct way, so you might be thinking about the Morris traversal, because Morris traversal gives us the in order in O1 space complexity, right? We can traverse in order in Morris traversal with a time complexity of O1. So this is what you have to think. So we are in this question, we are thinking about around Morris. Okay, we are going to think around Morris traversal. So how we can solve it? Using Morris traversal. So this was the hint. Okay, so now we will begin the question and we are going to solve it. So how we can solve this question? We know how to traverse in Morris traversal, how to traverse the in order, we know that in order is being sorted. So if there is some change in order, we can identify that change. uh, we can identify those places. Okay, we can identify those places. But you have to do this in Morris, right? You have to do this in Morris. So you have to think that how you can do this, because there is one more way. There is one more way in which you can do that, and that way is you will store all these in an array, all these elements in an array. And what you will do, you will simply check out the places where there is some change, and then you will simply swap them. Okay, but here you have used the space of O(n). You don't have to do this. You have to do this in O(1) time complexity. You don't have to use any extra space. Okay, so how you can do this? So let me tell you the approach. So for this, for thinking about this approach, you have to see one thing, that is the graph, not the data structure, but the graph of this array. So see, if it is an ideal BST, then what should be the graph look like? What should the graph look like? So if I'm not wrong, then for a sorted line, that means what it means, when I'm increasing the index, the numbers or the elements or the values are increasing, right? When I'm increasing this, at 0 index it was 1, at 1 it was 3, at 4 it is, at 2 it is 4, at 3 it is 10, right? Earlier it was 6. So in a BST, not in this changed BST, but in an ideal BST, the sorted order is I mean the in order is sorted, right? So for sorted thing, like for increasing order, you must have seen an equation, that is y is proportional to x, right? What this means? This means that when we'll increase our y, this x will be increased. And how was the equation for this? You must have read the equation for y is equals to mx. It is a equation of straight line. So this will look like this, right? So this will look like this. So now how this straight line, okay, I know that it is sorted. Okay, I know that it is sorted. I know that this line will go like this. But how this graph and this line is helping me in determining the points where there is a change? How? See, you have thought about the actual thing, like the actual BST graph, right? But think about this graph now, how this will look like. So as there is only two change, right? Or as there is only change in one pair, that is change in only two nodes. So suppose a node from here is being taken and a node from here is being taken, right? And these two are being replaced. So how it will look like? If I'm not wrong, then it will look like uh this will go here and this will come to this, right? So if I'll make a graph, like if I make some points, then it should be it would look like this, right? So now if I'll remove these points and these also, this is how my graph will look like, right? This is how my graph will look like when it is being changed, when the values are being replaced. So this is what the graph I'll get. Okay, there is some peak and there is some downfall, right? Some peak will come and some downfall will come. So how it will be? See, let me tell you with the help of coordinates. Okay, let me tell you with the help of coordinates. So think, if I talk about this point and this point, okay, so let us think with the help of this array only. So earlier, suppose it was, let us assume that this is index 0. So this signifies index 0. Here my x line is index, my y line is values. Okay, x line is index, y line is values. So at 0 it is 1, at 1 it is 3, at 2 it is 4, right? At 2 it is 4, at 3 it is 10, at 4 it is 7. Okay, at 5 uh okay, at 5 it is 7, at 6 no, at 5 it is 7, Okay, 7 is here and it is 8. Okay, and it is 8. So it will look like this 13 and this 14. So what it will do, see, suppose it is some let me say some random like it is 2 index and the value here is 5. Okay, earlier it was 5. I'm just assuming it, not taking it, because it is possible that you will be confused with indexing that I'm giving. Okay, you could be confused with it, so I'm giving the simple fine example. So that example could be, think about this point. Okay, this could be 2 and this is 5. Okay, it is valid. So this will be this this value would be greater than 5. So suppose it is 10, right? It is 10 here, and this also will be greater than this 2. So it would be, suppose it is 6, right? So what this point would be, this point would be 2 comma 5 earlier, right? So 2 comma 5, and this point there was earlier it was 5 comma or 6 comma 10, right? Earlier it was 6 comma 10. So now what change has been when it is this 10, this 10, it was 10, right? 10 was this y index. Now the y index is being shifted, the x index is being same here. Now it is only 6, right? X is already, earlier x was 6 and right now also x is 6, right? So x index is not changed, but my y is changed. So when my y is changed, what I'll do, I will simply see that earlier there was 10 and now there is 6, I mean 5 comma 6 will come in the first, right? So it is 6 comma 5. So I can simply see that there is a downfall. 10 is being changed to 5, so there should be a downfall, there will be a downfall. Okay, and here I can see that earlier it was 2 comma 5, right? And now it is 2 comma 10. X is same, but the y is increased, so there is 2 comma 10. So this peak will arise, right? This peak will arise. Okay, I hope that this point is clear, right? Okay, so let us go to the original graph. This was my original graph. So how I can solve this question using this? See, what we can do, we can simply take 2 pointers. We can simply take 2 pointers, a current, one thing, I'll write this graph little bit this side, and I'll take 2 pointers now. That is a previous pointer and a current pointer. Okay, suppose my previous is here, my current is here. Okay, I'll keep on checking. I'll keep on checking that if previous is greater than current. So what will happen if previous is greater than current? First of all, tell me that what should be the order of this previous and current, if this array will be sorted. If this order is sorted, then the relation is previous will always be less than current, right? Previous, that is the one that is coming before, will be less than, or will always be less than the one which is coming after that, right? C is coming after previous, right? Current is coming after previous, so current will always be greater because it is a sorted array. But there will be a point where I can observe that this previous is greater than current, right? There could be an ambiguity because there is some change. That means an ambiguity will occur at that point. Okay, and when I'll see that change, I have to mark those points. And I have to find the possible changes, that what are the possible changes at that point. So what I'm saying that I will check for P is greater than C. Okay, I'll check if P is greater than C or not. Okay, that means my previous is greater than current. C, at this point, is my previous greater than current? No, previous is less than current. Move on. Is previous greater than current? No, previous is less than current. Is previous greater than current? See, one thing, here is my change, right? Here is my change, but at this point also I cannot recognize my change. I can recognize my change only when my previous will be greater than my current, right? My previous is now greater than my current. That means at this point there is some ambiguity, right? See, let me show you something, that is previous is greater than current, right? So we were at the point, just a minute. Previous was here, current was here, and we moved first from this, and then we move to this, right? So at this point also we were not able to identify the change because the order should be greater than greater than greater than greater than, and then I mean the current is greater, right? Current is greater, current is greater, current is greater, but still here it is 10, right? Here it is 10, but here also the current one is greater, but at this point current one is smaller. So when current is smaller, or we can say when previous is greater than current, at this point we can identify that there is some ambiguity, and we have to store those two possible points. Okay, so we will store a is equals to what we will store, a is equals to a will be equals to 10 and b is equals to 7, right? So b will be equals to 7. So these are the 2 points which we have to store. So what we will do, we will now change it, and we will move forward. So now we first of all we have seen that there is 2 possible points, right? We have seen 2 possible points. So what are those 2 possible points? First is 10 and second is 7. Okay, but now we know there could be one more point. There could be one more point, like it is not true that a will be equals to 10 only and b will be equals to 7 only, right? But there could be a surety about about one element, that is about p, or from p or c there is someone who is at the correct place, right? Suppose p is at its correct place or c at its correct place. You have to find out this point at this at this time. You have to find out that if p is greater, I mean if p is at the correct place, or if c is at the correct place. That means, are we at the correct place? See, it could be a little confusing, but I'll try to make it simple. Let me tell you again. Okay, let me tell you again. So at this point we will store these points. A is equals to p. Okay, that means a is equals to 10 and b is equals to c. That means b is equals to 7. Okay, now what we will do, we will simply move forward. Okay, is previous greater than current? No. Is previous greater than current? Yes, it is. So now we will store it again. So again, suppose if I'll again make a is equals to 8, then will it be right? Or if I'll make b is equals to 6, then now it will be at the right place, right? But I don't need to change this, right? If I change this, then I'll lose my this a is equals to 10. But I need answer as a is equals to 10 and b is equals to 6, right? Because these two are the changes. So how I can identify these changes and how I can stop it in the right place? So at what you can do, you can think that when my p and c was here at this point, right? P is greater than c, right? At this point, when my p and c were here, what you can observe, you have to think that there is the first ambiguity. It is the first ambiguity place, right? It is the first place where ambiguity has been occurred. So what you have to think, that there is a number which has been placed here from the forward. See what I'm saying? This number 10, I'm saying this is coming from this right side or the forward side. Okay, and same thing for this, like when I'm reaching here. Okay, let's not talk about that. Let us talk about this only. Okay, so I'm saying that this number 10 is coming from the right side. This is coming from the right side. So what it means, it means that this one, that is, see, 1 is at the right place. Okay, we moved on. 3 is at the right place, we moved on. 4 is at the right place, we moved on. But still, when p is here and c was there, at this point we have observed that we should stop, we should collect the c, but we were not able to. Why? Because the order was same. When someone is coming from the forward, then we cannot say, when someone is coming from the forward and that is already greater than me, so I cannot find that, if I cannot find with the check p is greater than c, that if it is greater than me or not, if it is the change or not. Okay, I cannot find with it. So at this point I should say that this one is the possible change. Okay, this previous, this a was earlier the possible change. Okay, was earlier the possible change. And when I'll move forward, when I will move forward, then I will see that at this point my previous is greater than current, right? my 8 is greater than 6. At this point my 8 is greater than 6, so I can observe here at the second ambiguity point, my current is my possible change. Okay, current is my possible change. Okay, so I hope that it is clear. And now what I'll do, I'll take one more example so that you could be more clear about it. Okay, you could be more clear about it. So let us make one more graph. Okay, so I hope that it is clear. Okay, I hope that it is clear. But for it I'll take one more example so that you could be more clear. But this time what we are going to do, we are going to take an array. We are going to take some numbers which are just nearby of each other, right? Suppose the 10 and 6 were changed, right? So let me write here 10 at the original place, 6 at the original place, and now we'll replace 7 and 8. Okay, now we'll replace 7 and 8. So let us replace 7 and 8. So 7 is 10, 8 is, oh, I'm sorry, 7 is 8, right? 7 will be written as 8 and 8 will be written by 7, right? So here is the change, right? Here is the change, and we will also write it with some other color so that we can highlight them. 7, 8. After 6 the 7 will come, right? After 6 the 7 should come, but actually the 8 is coming. So we'll write 8 after 6, 8, and after this 7, right? After this 7. So it is the change. So what will be the graph this time? See, it was the original graph, right? It was the original graph, but now as two nearby values are being swapped, so what could be the possible graph? See, now I just have zoom it so that I can make the graph properly. Okay, I'll again zoom out it. So what I'll do, I'll just simply mark the point. See, earlier it was here, right? So the next point should be, this point is being shifted to this, and this point is being shifted to this one. So graph will look like this one is here, and this one is here, right? Graph will look like this. And if we'll erase these points, so how it will look like? See, it will look like this. Okay, so this is the change that is being seen. So this is the change that is being seen. So what we can do with this change? Again, we are going to do the dry run. So again, put two pointers. Again take two pointers, that is previous and a current. Okay, so what we will do, we'll simply check if previous is greater than current. No, it is not. Move. If previous greater than current, no, it does not move. Previous greater than current, no, it does not move. Previous is greater than current, no, move. Is previous greater than current? Yes, there is an ambiguity. Collect these points. So A is equals to 8 and B is equals to 7. Okay, these 2 points are being collected. So what we can do, we can move forward from here and we'll check if there is some again ambiguity or not. Previous greater than current, no, right? 7 is less than current, so it will move forward. Now 10 is less than 13, move forward. 13 is less than 14, move forward. It will go out of this array. So now we will see that this will stop, and we have reached the point where we got only these two changes, these two persons. So at this, in this case, we don't need to handle that previous or current again, because in the previous one, let me take you to the previous one. In the previous one, it was the one, right? So in this, if you can observe, let me tell you again. Okay, so let us erase this and let us see this again. Okay, so I hope that was clear, right? On in when there is an interchange in just the point which are nearby to each other, that means which are adjacent to each other, at that point we can see only one ambiguity, and after one traversal only we will get the right place. Okay, but in this case we have to handle it with the traversal. Okay, so what we can do, suppose initially we are taking a at null, b at null. Okay, both are null. I'm not taking this extra space. Okay, don't think that I'm doing this in an array, I'm filling an array and then I'll check by two with the help of two pointers. I'll not do that. I'll not take any extra space. I'll do the Morris traversal only, and in that Morris traversal I will find out. Okay, in that or Morris traversal I will find out this. So how? Let us see. So here my a is null, b is null. Okay, so a is null and b is null, but previous is at this, earlier previous was also null. Okay, earlier previous was also null, and when I'll get the first element in my Morris traversal, I'll fix my previous. So suppose I'll start my current from the head. Okay, from this point I'll start my current, or we can say I'll start my current from this. Okay, so what I'll do, when I'll reach here in the Morris traversal, right, this will be the first element which should be added, right? So what I'll do, after this I'll reach to this, right? But I will not only reach to this, I'll shift my previous to this on this also. So when I'll reach to 3, my current will here, I'll shift to my previous here, right? And then I'll keep on shifting my previous. Okay, so there is only one point where I need to change my previous. Okay, and after this my previous will not be equals to null. That is what I'm telling you. Okay, previous is not null after that, right? There is only one time where the previous is null, that is when I have visited the first element, when I have visited this first element. Okay, so let us move forward. Here my previous is less than current, here again my previous is less than current. At this point my previous is greater than current, right? My previous is greater than current, my 10 is greater than 7. So what I will do at this point, I'll see that there is some change, there is some ambiguity at this point, so I'll note it down. I'll save it in A as 10 and B as 7. Okay, but as I know that it is the first change, so that means there is someone who is coming from the forward side to the backward, right? From the right of the array someone is coming to the left, so that is why there is a peak is being created, and after that there is a downfall. Peak then downfall. So is which one is responsible? Is previous is responsible or current is responsible? So I will say my previous has been responsible here. Previous is responsible here, because if someone is coming from forward, if someone is coming from the forward, then if my previous was here and current was here, so at that point also that will say that it is right, it is sorted, right? It is in the ascending order only. But after reaching at this point, I'll see that my previous is telling me that I am the change. So I will save this previous in A, right? I'll save this previous and I'll move on. And I will move on. So let us move on. So now this will go to this will go to this, and here again I'll see my previous is greater than current, right? So now which one is telling me? Let's write this thing. Let me erase these points. So I hope these are clear. So I'll erase these, write it again. My previous was here, my current was here, my A was equals to 10 and B was equals to 7, right? So now my previous is at 8 and current is at 6, right? So now it is telling me that my previous is greater than my current. So now I can see that if I have visited a change previously, I know that I have visited a change previously and I am visiting this change second time. I'm visiting the ambiguity second time. So as I'm visiting a ambiguity second time, so what I'll say, okay, there is only one pair change, right? There is interchange of one pair only. So that means that someone has already been checked in the front. I am the second one which is saying that it is wrong. Okay, I am the one which is saying that it is the second change. So if I'll observe, then I'll say that which one is making the order wrong, the one which is smaller, right? The one which is smaller. So here the current is smaller. Here the current is smaller. Current is saying I am the one who is responsible for this ambiguity. So that means the one who is coming after, or the one who is in the current at this point, is the responsible one, right? Is the responsible one, or is the one which is being changed. So we'll change this B as 6. Okay, so we will make these two changes, and this will happen in our code also. Okay, so let us go to write the code. Okay, so let us now look into the code. So okay, so the code we are going to do in the C++, and let us write. So what we are going to do, let us see. Okay, so we are going to take the help of Morris, right? So we are going to take the help of Morris traversal. So how we were traversing in Morris traversal? So it was, we are not going to discuss Morris traversal here, but let me write it as soon as possible. So how it is, first of all, tree node current, right? We need current is equals to root, and then while current is not equals to null, ptr. One more thing, we need 3 more pointers, that is tree node previous is equals to null, right? And 2 more, that is a and b, right? So here now what we will do after this, see, tree node, we'll simply make a tree node, left node is equals to current dot left. Okay, and after that what we'll do, we'll check if current is, I mean if left node is equals to null or not. If it is null, that means that we are at the last point, and here we used to get the element of our in order. So first of all we are going to check here. So what we are going to check here, I'll write that after that, because as when we are reaching at the in order, we will check only at that time. Okay, because we are moving in order only, so we will take previous and current, so we will move into the tree only. Okay, not going to take any extra space. So let us do the work which we used to do here. So current will move to current dot right here first of all. Okay, and the other thing is we used to get the in order from here, so we will current rigst. Okay, so it would be current arrow left. Okay, and anything else? Okay, I hope everything is correct. Tree node star left node. And now here what we used to do, we used to make a tree node, a rightmost node is equals to, I'll make a function get rightmost node, and in this I'll pass left node and I'll pass current. Okay, and after this I used to check if my current, I mean my rightmost node right is equals to null or not. If it is equals to null, that means at that point I need to make some connections, and at the time of making connection, nothing will be added in my pre-order. So I mean my in order. Okay, so what I will do, I will simply okay, I need to make the connection here. Okay, so let us make the connection. So rightmost node dot right will be equals to current. Okay, and second thing that I need to do here is current will move to current dot left. So this is what I'll do, and here I need to break the connection. So how I'll do, right most node dot right equals to null, and also current will move to current dot right will move to the right side. So this is what happens here. And also we used to get in order here because it is the point where my left tree is being processed. I already told you in the in order video. So let us write this code. So how we are going to check it? So first of all, we will check if my previous is not equal to null. That means if we are visiting this the first time, okay, if we are not visiting this the first time, if we are visiting this first time, that means if we are visiting the first element of our in order, then how we will compare it? From which element we are going to compare it? We cannot compare it with our previous because previous was null at that time. Okay, only one element is itself a sorted element, right? So we cannot check if it is not sorted or not. Okay, so simply when previous is not equals to null pointer, at that point we'll check and we will write and my previous val, if it is greater than my current val, right? If it is greater, then at that point what we will do, at that point we will simply say a is equals to previous and b is equals to current, right? This is what I have told you. And also we need to shift this, our previous will be equals to our current, right? And current will move to its right. Okay, so now what we'll do after this, see, is it completed? I already have told you that we are going to change current only this b. We are going to change only b at the point if we have already visited one ambiguity, then at the second time we are going to change this b only, right? We are not going to change this a because a is at the right place because there is only two changes. There is only change of one pair, so that means we are not going to change this a, we are going to change this b. So we will make a check here that if a is visited, if this ambiguity has been occurred only first time, then change a. That means if a is equals to null pointer only, at that point change, at that point only change this a, otherwise change b. Okay, otherwise change b. So the same code I'll write for the second place where I'll get my in order. So at this place I'll get my in order, so I'll write the same thing for there. Now what I'll do, I will write a function to get tree node star get right most node, and in that I'll write tree node star left node comma tree node star current. So what I'll do, I'll simply write okay, while my left node is not equals to null and left node is not equals to current, and at that point move the left node is equals to right of left node, and then return simply left node. Okay, so this is almost done. Tree node current previous ab, and this is left node. So previous that val is greater than current dot val, and yeah, we are almost done. And but what we are missing, so the one thing that is missing is we found the point where there is some ambiguity. Okay, we found a and b, but we need to recover our bst. So how we can recover it? We will check if I meet some ambiguity. That means if a is not equals to null, earlier it was null. If a is not equals to null, then what we will do, we will simply take temp is equals to a, and we'll shift a val is equals to b val, and b val is equals to temp. Okay, so let us give it a run now. So it has been accepted, and let us give it a final submit for all the test cases. So the code is accepted, so I hope you got the point, okay, and the code completely. So after that, we'll meet in the next video, okay. So don't forget to like the video and subscribe the channel and share it with your friends also. So till then, goodbye, take care.